right? So yesterday we talked about substitution. Today we're talking about elimination. Here's the steps for elimination. What you guys do is you try to get the coefficients of one of the variables to be exact opposites. Same number, different signs, one positive, one negative, and then they'll cancel out. So if you have this, guys, there's a bunch of different ways to do this problem. You can cancel out the y's, you can cancel out the x's. You guys can do whatever you want. Does not matter if I cancel out the x's, but what is easier to do in this question? Cancel out the y's. Why is it easy? It's already set up like that. It's already set up to cancel them out. If I combine these two equations, if I add them, what's 3x plus 5x? 8x. Positive 2y, negative 2y cancels out. And then what's 4 plus 8? 12? All right. So how do I solve for x? What do I do? Divide both sides by 8. And then I get x equals what? What's 12 divided by 8? What does that reduce to? 3 over 2? Okay. Can I also write that as a decimal? Can I also write that as a decimal? Yes. Do you have to? No. However you guys want to write it is fine. Now, the way that you find out, I found out what x is. How do you find out what y is? You plug it back in. So I'm just going to use the top one because it looks easier to me. So I have 3 times 3 over 2 plus 2y equals 4. You with me? Okay. Can I cross cancel anything here? No. So 3 times 3 is, I have 9 over 2 plus 2y equals 4. Now what? Okay, subtract 9 over 2 from both sides. So 2y equals, what's another way I can write the whole number 4 if I have 2 as a denominator? 4 over 1, which is the same as 8 over 2, right? You guys agree with me? So what's 8 over 2 minus 9 over 2? Negative 1/2, negative 1 over 2. And then how do I solve for y? Divide both sides by 2. So y equals, I have negative 1/2 divided by 2. What do I do here? Keep, change, and then I flip. 2 over 1 becomes, whoops, 1 over 2. So y is what? Negative 1/4. You guys agree? Negative 1/4? Yeah. Okay, so I can write my ordered pair as x is 3 over 2 and y is negative 1/4. I don't mind if you write your answer to this in decimal form. Why do you think it's okay for me to put a decimal form here, but it's not in other cases when I have fractions? Because it's not as precise. This is a terminating decimal. 3 over 2 is the same as 1.5, right? And negative 1/4 is the same as negative 0.25. Since they are terminating decimals, I don't care which one you write. But if you got like 1/3, I don't want you to write 0.333 and then put lines over it, right? If you get a repeating decimal, then I don't want decimals. Now, how do I know if I'm right or not? Plug it back in. Very simply, guys, you guys can plug this back in quickly. If we look at the first one, I have 3 over 2. I'm going to plug in for x. And then I'm going to plug in negative 1/4 for y. Does that equal 4? Well, so I have 9 over 4 minus what? Negative. So, right, I'd have negative 1/2. Which is what? Okay, I did right here. Thank you. It should be 3 times 3 over 2 plus 2 times negative 1/4. Thanks, buddy. Equals 4. Look, I multiplied. I don't know why I got 4 on the bottom here. I multiply the top. 3 times 3 is 9 over 2, right? Mm-hmm. Silly me. Minus what? 1 over 2? Equals 4. What's 9 over 2 minus 1 over 2? 8 over 2, which is? 4. Okay. Woo. Thank you, sir. I was like, what? What's up? Okay. Oh, I hate when I make mistakes like that. All right, look at this one. All right. Is it set up nice and easy where we can just eliminate without doing anything? No. Which would you like to eliminate, the x's or the y's? I'm going to do the y's first. Carlos, I agree with you. And the reason I think the y's first would be easier because one of the y's is positive and one of them's negative. You guys see that? So in order to get your coefficients to be exact opposites, I would have to multiply the top and the bottom by something and the entire thing. So what am I going to multiply the top equation by and the bottom equation by to make the y's cancel out? What would you guys do? Perfect. And I have to multiply everything on both sides of the equal sign. Super important. So 4 times 5 is 20. So 20x. God bless. 4 times 3, 12y. And then 4 times 9 is what? 36. All right, now the bottom. 3 times 2 is 6x. 3 times negative 4 is negative 12y. And then what's 3 times 14? Perfect. Now, when I combine these equations, my y's will cancel out. So I have 20x plus 6x gives me 26x. Negative 12 and positive 12y cancel out. And then what's 36 plus 42? 78. All right. Now what? Divide 26 on both sides. And I get x equals? X equals 3. Okay. So now that I found x equals 3, how do I find out what y equals? Plug it back in. You plug it back into whichever one you want. I'm going to plug it back in the top because there's no negatives. So I'm going to say 5 times 3 plus 3y equals 9. So 15 plus 3y equals 9. Minus 15 from both sides. 3y equals what? What's 9 minus 15? Negative 6. And then divide by 3, so y equals? Negative 2. And how do we know we're right? What would we do? Plug it back in. Now, guys, if you leave your answer like that, it's a 10-point question. I'm taking 2 points off. How do we write our answer? As an ordered pair. 3, comma, negative 2. Questions? Anybody have questions? All right, this should be a review here. You guys should know this. Where graphs intersect, right? Those are their solutions. So if you have 2 lines, right? I got a line here and a line here. Right here, where they intersect, that's their solution. If you had a parabola and a line, how many solutions does this have? 2 solutions. They cross there and there, all right? Infinite many is when the lines coincide. It's when it's the same line. All right, so if you had 2 lines graphed, one of the graphs looked like this, and then the other graph looked like this. Do you see how they are on top of each other? They coincide. That means anything along that line will satisfy both equations. And then when you have 2 parallel lines that never, ever, ever touch, that's when we have no solution. So graphically, you guys should be able to tell very, very easily what the solutions are and where they are. Wherever the 2 graphs cross, that's their intersection point, that's the solution. If they don't ever touch, it's no solution. And if it's the same line, it's infinite many solutions. Algebraically, we're going to look at it a little differently. All right, look at these 3 graphs on the bottom. Or in the middle, I guess. What's the first? Is it no solution, 1 solution, or infinite many solutions? Infinite many. What's the second one? None, because they don't touch. And then what's the last one? 1. All right, we're going to work these out algebraically, and I want you guys to see how this works. Now, again, cross off, eliminate whatever you want to say, whatever variable you want. So you guys pick. Tell me, and I'll do it.
The x's.
Okay, if I eliminate the x's, then I'm going to multiply The top by what?
Positive 2.
Positive 2. Yeah, you're fine. So 2 times 2 is 4x, right? 2 times negative 3 is negative 6y. And 2 times positive 3 is 6. You guys agree with me? Okay, be careful on these. These seem really simple, just really easy to make silly mistakes. What's a negative 4 and a positive 4 equal? Cancels out. 0, right? What's a positive 6y and a negative 6y? 0. Cancels out. What's 6 plus 6? 12. So this says 0 equals 12. Is that a true statement? No. So what is my answer here? No solution. If you had to pick the graph that went with this, you would pick this graph right here. If you get 0 equals a number, or a number equals a different number, 3 equals negative 4, that's never going to be, so your answer there would be no solution. Questions on that?
So infinite and...
All right, let's look at B. What do you want to cross off on B, guys? The x's. Okay, so we're gonna multiply the bottom here by negative 2.
Yeah.
Okay, so I'm gonna write it on. Well, no, I'm gonna rewrite. So I have 2x minus 3y equals 3, and then underneath it I'm gonna have negative 2x. Agreed? Minus 2y equals negative 10. Yes. Sorry, my brain is not functioning today. We got a game today, and I'm trying to think of all the things I'm trying to do here. All right, let's do this again. Negative 2x, negative 2 times 2 is what? Right?
4x. I'm sorry, y.
4y. And then negative 2 times 5 is?
Negative 10.
Negative 10. All right, so what cancels out? 2x and negative 2x. Then I get negative 3 and negative 4 gives me negative 7y equals, what's 3 minus 10? Negative 7. Divide both sides by negative 7. And I come out with something. I come out with y equals 1. Now, how do I find out what x equals? Plug it back in. So I'm going to plug it into that second equation. I'm going to say x plus 2 times 1 equals 5. So x plus 2 equals 5. What does x equal? X equals 3. So my solution here is at 3, 1. How many solutions does this set of equations have? 1. So if you were going to graph it, or you're going to pick the graph, you would pick this graph because it crosses at that 1 point, 3, 1. All right, let's look at the last one. We've had a no solution. We've had a 1 solution. What do you think this one's going to be? Infinite many. All right, watch what happens here. What do you guys want to cross out, the x's or the y's? The x's. Okay, so we're going to multiply the top by 2. Agreed? Okay, so I have 2 times 2 is 4x. 2 times negative 3 is negative 6y. And 2 times 3 is 6. So when you combine, what happens with negative 4x and positive 4x? Cancels out. Negative 6y, positive 6y. Cancels out. Equals, what's negative 6, positive 6? Nothing. When you come out with 0 equals 0, or a number equals the same number, that is your infinite many. That's when you have the line that coincides right here. That's what you would pick. So your algebraic answer here would be infinite many. So do you see the difference between, algebraically, between no solution and infinite many? Deanna, you see that? No solution, you'll come out with a statement that is not true. 0 does not ever equal 12. When you come out with a number equals itself, then that's infinite many. And then when you come out with y equals or x equals, that's your solution point. We good? All right, let's look at the last one. What do you want? What do you want to eliminate? X? Okay. So I'm going to multiply the top by 2. So I have 2 times x is 2x. 2 times negative 2 is negative 4y. And 2 times 3 is 6. cancels out, equals 7. Does 0 equal 7?
No.
So your answer here would be
No solution.
no solution.
No solution.
No solution. Good. Now, that's it for today. This is just a review, but let me bring something to your attention. Say you guys had something like this. All right away we look at this and we don't like it. Why?
Fractions.
Is there something I can do algebraically that I can make this all linear with no fractions? Yep. If you get a common denominator, what would be a common denominator between 3, 2, and 1? 6. So watch. Can I multiply everything by 6?
Yeah.
Yeah. What would happen in the first fraction with 6 times 1/2? What would that become? 3x. 6 times 2/3. What would that become? 3 goes into 3 once. 3 goes into 6 how many times? 2. And then 2 times 2 would be 4y. And then -6. You guys see what I did there? Whenever you have fractions, if you guys, some of you don't mind fractions, that's fine. But a lot of us don't like them. So don't change it into a decimal because 2/3 is going to give you that 0.66666, and that's not good. So just find a common denominator between all of them and just multiply by that whole number, and then it'll cancel out all of your fractions. These two equations right here are equivalent. They look a little different, but they are equivalent.
If you were to find the answer, would you have to convert them back?
Nope, good question. No, it'll work itself out. All right, we good?
Feel better?
That's it. What's up, babe?